So this 4.6 video is brought to you by an underwater explorer. I forget the name of these Lego guys. Something's happening. He's getting nervous. 4.6 is looking at another measurement of our data set. So we've collected our sample and we're doing some calculations with it. This measurement is called a measure of variation. Another word we use for this is spread. And if we compare this to what we learned in 4.5, 4.5 was looking at the center. So what is kind of the typical value or the center value, and this is how spread out are the data values from that center. We're going to talk about three types of spread, or three different measurements for it. One is standard deviation, the other is range, and then the coefficient of variation are the three things. And we're going to talk about what this tells us about a data set. So one of the lenses we look through is, here's two sets of dogs. This is a picture. These dogs all kind of look like they might weigh the same. They're all basically the same size. And here's another set of dogs where we've got these dogs that are relatively the same size, and then we got some smaller ones. And so based on their weights, there seems to be some difference in these dogs. Okay, so the simplest measurement is the range. And it's simply the largest value minus the smallest value. If we think about how we programmed the mid-range into Excel, that was the maximum value minus the minimum value. You can already tell that this is not going to be a great measurement. If you remember, the mean was not resistant to outliers. It was highly affected by outliers, because it included those large or small values relative to the data set in the calculation. Well, the range consists of only those largest and smallest value. But it does give you a really quick view of how far apart are the data values. So here's the weights of the dogs in those pictures. So the first picture, you can see from the weights, they're all basically the same. And the second, they're all pretty far apart. We're asked to find the mean, so that would be x bar. I'm going to use a little subscript 1 to show that this is the mean for the first picture. And I'm just going to go ahead and do this in Excel because it's a pretty quick calculation. It's 70 plus 73 plus 58 plus 60. That number divided by the 4 animals that were in the picture. And the mean weight we're getting for those dogs is 65.25 pounds. Now, I'm then going to do the range for that, which is the biggest number, and by inspection I'm seeing that's 73 minus the smallest number, but again by inspection I'm seeing that's 58. And so the range of picture 1 happens to be 15 pounds. So the mean for the second picture, there's a few more data values in there, but it's okay. There's not too many. I can quickly type them in. 30 plus 85 plus 40 plus 125 plus 42 plus 75 plus 60 plus 55. And that was 2, 4, 6, 8 dogs in that picture. Would you look at that? The mean is basically the same, 64 pounds. But let's check out the range. So the largest value in there is 125, and the smallest value in there is 30, a range of 95 pounds. Okay, so there's those sizes or the weights of those dogs are quite spread out. Here, the center value, when we look at the measurement of average between the two data sets, they're basically the same, whereas the range is really far apart. So the difference between the largest dog and the smallest dog is quite large. It might be that we would call this 125 and this 30 outliers, and so this is not a very good measurement of average or center for that second picture. And so maybe we would want to talk about the median. Well, let's just do that. Why not? Actually, now I don't want to do it because we have to do calculations. So let's skip that. Means are basically the same. ranges are very different. We already said it's limited because it uses potential outliers. Data values that don't really fit with the other data values. Okay, so the second measurement that we talk about is a little bit better of a measurement for spread or variation, and that's the standard deviation. And it's a little bit complicated. It's definitely complicated in its calculation, but the basic understanding is that it is the average distance that each data value is away from the mean. So if the mean was the best measure of the center, what this thing measures, the standard deviation, it measures the average distance all of the data values are from that good center measurement. And that will tell us if things are really spread out or if all the data values are pretty well clumped together. So one of the interpretations here that were said is that if the standard deviation that's relatively large to the mean says that the data values are pretty widely spread out from the mean, and if it's relatively small, then they're fairly close to the mean. So let's say our X bar was 100, and then our standard deviation, for now I'll just call it this, was 10. That's kind of small relative to the mean, whereas if our X bar was 100 and our standard deviation was, let's say, 50, that's saying that relative to the mean, it's quite spread out, because this is half the mean, where this is a tenth of the mean. There are two types of standard deviation, and there are two calculations for it. So there's population standard deviation, that we use the sigma symbol for, and there's sample standard deviation, which we use S for. That's a terrible S, my goodness. There are slightly different calculations for each of these. You're going to use, you'll see the formulas in Desmos and Excel. One of them has population with it, one of them does not. And the only way you will know which version to use is whether or not you know the data set came from a population or came from a sample. So remember, population, you're looking for or thinking about the word all. Does this data set contain all of the possible data values? And if we're talking about a sample, you're thinking, was this some of the possible data values? So you need the context clues to determine, should we be using the sigma formula in our calculation, or should we be using the S formula in our calculation?